Hello friends, welcome to DITWAH. My name is Kumar Anuj. My friends, the topic of our today's discussion is cyclone DITWAH. It was recently very much in news, of course due to bad reasons, but since it was in news, it becomes important for our exam perspective. So here in this discussion today, we'll try to look out all the perspectives related to this entire development that could be important for our upcoming exams. So my friends, this cyclone named DITWAH, it is a tropical cyclone. It is a tropical cyclone that formed over southwest region of Bay of Bengal. Formed over southwest region of Bay of Bengal, which is close to the Sri Lankan coast. And after getting formed, it started traveling towards the Sri Lankan coast, towards the northwestern region, towards the northwestern side, and on the way, it hit the Sri Lankan coast. It hit the Sri Lankan coastal region, my friends. Sri Lankan coastal region. And it caused tremendous damage there in the coastal area of Sri Lanka. Tremendous damage. Damage in form of loss of hundreds of lives, displacement of lakhs of people, and it also affected directly or indirectly millions of people. So due to that huge devastation caused by this cyclone, specifically in the coastal region of Sri Lanka, the president of Sri Lanka, Aruna Kumara Dissanayake had to declare a nationwide state of emergency to mobilize the resources and to tackle the crisis. So that's why it became extremely devastating, specifically for Sri Lanka. And India also launched an operation to help Sri Lanka out of the situation. The operation is named Operation Sagar Bandhu. Operation Sagar Bandhu. Extremely important, that could be for our upcoming exams. Operation Sagar Bandhu. It was launched by India to help Sri Lanka out of the situation, since this cyclone was causing tremendous damage there. Because of that, the national state of emergency was declared in Sri Lanka on 29th of November. On 29th of November, my friends. And after that, this cyclone just again coming over the Bay of Bengal region in between, started approaching towards the Tamil Nadu, Andhra coast of India. But due to the cold water there, comparatively cooler as compared to the water where it originated. So due to the cold water in the coastal region, it got dissipated before the landfall, meaning before reaching over the land areas in India. So it could not cause that much amount of damage in India as it caused in Sri Lanka, because it got dissipated before the landfall itself, before reaching the land areas of India. So it got dissipated close to the Tamil Nadu, Andhra coast region of India. But it caused some noticeable damage in India as well, specifically in form of heavy rain and flooding. And this cyclone, it was named DITWAH. The name was given by Yemen. So these developments, these things with respect to this particular incident, this particular cyclone, they become important for our exam perspective. I mean, what was where it got originated? It got originated in the southwest Bay of Bengal region. Then after it hit the Sri Lankan coast area. coastal region. And due to that, a nationwide state of emergency was declared by Aruna Kumara Dissanayake, the president of Sri Lanka, on 29th of November, my friends. And to help the Sri Lanka out of this entire situation, India also launched Operation Sagar Bandhu, extremely important, my friends. This could be the part of any question in our upcoming exams, that which operation India launched to help Sri Lanka out of the situation that was caused by cyclone DITWAH. So this could be the part of our question. Then I'll have to find out the right option mentioning Sagar Bandhu, Operation Sagar Bandhu, my friends. Now, this entire development, this entire kind of, we can say that incident that is associated with this particular cyclone DITWAH, we just should keep in mind the important aspects associated with this particular incident. But as aspirants of civil services exam, some more questions are needed to be answered. For example, what is a tropical cyclone? How it gets formed? In what form? How it causes damage? How it dissipates? How it is named? Various aspects associated around this entire development, they are important, they are needed to be answered. So my friends, we should look into all those aspects and try to find out the answers of each of that question. So come on, my friends, let's see that one by one. For example, if we talk about a tropical cyclone. So my friends, a tropical cyclone is a tropical cyclone is a rotating low pressure system. Low pressure system. Simply putting, it is a rotating low pressure system over the warm oceanic water. Warm oceanic water. So this is the simple definition, the most simple definition we can just give to a tropical cyclone. Remember, here we are talking about tropical cyclone, since DITWAH was a tropical cyclone. So it is almost a kind of rotating low pressure system over the warm oceanic water. And over the warm oceanic water, and it is also accompanied by strong winds, heavy rain, heavy rains, and thunderstorms. Now, my friends, this is a tropical cyclone. What does it mean? It means that these types of cyclones, they originate specifically in the tropical region. In between, specifically Tropic of Cancer and Tropic of Capricorn. They originate specifically in this region of the earth. So talking about the entire development with respect to the tropical cyclone, my friends, we see we just try to understand in step-by-step manner that how the things unfold. For example, there is warm oceanic water. The surface temperature should be at least 26 degrees Celsius. 26 degrees Celsius, at least. Surface temperature at least 26 degrees Celsius. 26 degrees Celsius. And since the surface temperature is enough, so this surface temperature of the ocean, it causes evaporation, it warms the wind above the surface of the ocean, which is warm enough. It also warms up the wind above, the air above. And since the surface of the ocean, meaning the water, is warm, so the evaporation is also taking place. And that evaporation also makes the air above the moist air. So this warm oceanic water, it warms up the air above, and also makes it moist because of the evaporation that is taking place here. And this warm, moist air, since we know the warm air, it rises up because it is less dense as compared to the cold air. So this warm air, it rises up. When the warm air rises up, for example, this is the surface of the ocean, and the temperature is more than 26 degrees Celsius. More than 26 degrees Celsius. The surface temperature of the particular water body, particular ocean. And the air above the surface of the ocean, it gets warmed up because the surface temperature of the ocean is enough to warm up the air above. And since the surface temperature of the ocean is more, so it also causes evaporation to take place, meaning water vapors. And those water vapors, they mix into this air. And this warm air, since warm air is less dense as compared to the cold air, so this warm air, this starts rising above, leaving a gap here, meaning low pressure area. This is called a low pressure area. So this rise of warm moist air, it causes a low pressure area here. And to fill this gap, the surrounding air rushes towards this low pressure area. The surrounding air, the air around this low pressure area, it rushes towards this low pressure area to fill in the gap that was created by this warm moist air which is rising up. And when this cold air fills the gap here, then it also becomes the warm air, because it is coming again into the contact of the warm surface of the ocean. So it also becomes same warm and moist air. And again, it starts rising above. And when it again rises above, it creates low pressure area, and again the surrounding air rushes in to fill into the gap, and this cycle takes place. When this cycle happens, we just call it convective low pressure system. This cycle is known as convective low pressure system. Low pressure system, my friends. Convective low pressure system, because convection is taking place here. Convection of air is taking place here. And this convective low pressure system, this supplies the required moisture the required heat for a tropical cyclone to get formed. For example, when this moist and warm air rises up, as much as it rises up, it becomes cold. It becomes cooler and cooler. And my friends, this moist air, as it becomes cold by rising up, because as much as we go upside in the troposphere, the temperature falls. And because of that fall in temperature, the air which is rising above, that becomes cooler and cooler, that becomes cold. And the water vapors that this air was carrying with it, they become water droplets due to the condensation. Because the temperature is falling, so the water vapor, they can no longer remain in the gaseous state, and they turn out to be into water droplets, my friends, under the process of condensation. And under this process, they also release the latent heat of condensation. They release the latent heat of condensation. The latent heat of condensation. Latent here means the hidden kind of potential heat. Potential heat which was already there in the water vapor, but that came out only when the condensation happened. Only when the condensation of water vapor happened into droplets of water. So that's what we call latent heat of condensation. Meaning the heat was there in the latent form, in the potential form, and it got expressed, meaning it came out when the condensation specifically happened. And this condensation, it also, since it changes the water vapor into the form of water droplets, so it also forms clouds, and these clouds, they cause rain. Now, my friends, this potential heat of condensation, which is released when the condensation is taking place, this heat again warms up the air, the surrounding air. And when the air again gets warmed up because of this release of heat, it starts rising more rapidly. It starts rising up more rapidly because now it got the heat that came out from this process of condensation. And when the air starts rising more rapidly, it just creates more strong low pressure below. And when the low pressure below is intensified, then the surrounding air, it rushes towards the low pressure system more rapidly. Meaning the surrounding air, it becomes more strong. Because now the low pressure system, the low pressure gradient is more strong. And that's why just the surrounding air, it rushes towards that low pressure system, that low pressure area to fill into the gap more rapidly. And this entire development, my friends, it just creates a stronger pressure gradient. Stronger pressure gradient. Stronger pressure gradient at the surface level. because now the low pressure area is more strong. So the gradient will become more severe. And because of that, the surrounding air will start blowing more rapidly towards that particular low pressure area. Now, my friends, this entire now development is known as tropical depression. Is known as tropical depression. Tropical depression. Tropical depression. Tropical depression. It is still not a tropical cyclone. It is a tropical depression which has been created. Now comes the role of Coriolis force, my friends. Coriolis force. Coriolis force. Coriolis force is generated because of the rotation of Earth on its axis, as we know. And this Coriolis force now provides the spin, the rotation to this particular tropical depression. Now this entire tropical depression, it starts rotating under the Coriolis force. And it starts rotating. It provides this tropical depression rotation or spin, as we call. Spin as we call. Now my friends, now the entire system, entire tropical depression, it starts spinning anti-clockwise in northern hemisphere. And if a similar tropical cyclone is taking place in southern hemisphere, then this spin is in the clockwise direction. In southern hemisphere. Southern hemisphere meaning entire area below 0 degrees Celsius. And northern hemisphere means entire area, entire region of the earth above 0 degrees Celsius. 0 degree equator line. 0 degree latitude. Sorry for that. So southern hemisphere meaning entire region of earth below 0 degree latitude. Northern hemisphere meaning entire region of earth above 0 degree latitude. So when similar tropical cyclone is taking place in northern hemisphere, it rotates anti-clockwise direction under the Coriolis effect. And when it is there in southern hemisphere, it rotates clockwise under the same Coriolis force. Now my friends, now since this particular system, now it got the spin as well, because earlier this system was just a tropical depression, but due to Coriolis force, now it became a rotating tropical depression. Rotating tropical depression. Rotating tropical depression. Rotating tropical depression. Now my friends, now this rotating tropical depression cannot travel by itself. It cannot move by itself. It can rotate because of the Coriolis effect, but it cannot move, it cannot travel from one place to another. For that, it needs steering winds, my friends, steering winds. For to move from one place to another, my friends, this rotating tropical depression, for to move from one place to another, for the movement, it needs steering winds. And what are the steering winds in the tropical region? Those steering winds, they are mostly trade winds. they are mostly trade winds. Trade winds that drive this entire rotating tropical depression from one place to another, meaning towards the, we can say that, western or northwestern side. This happens because of the steering winds, meaning trade winds, coming from the eastern side, blowing towards the western side, those winds. So under these winds, when this rotating tropical depression comes, then it starts having movement. And since these winds, these trade winds, they are moving from east towards western side or a little northwestern side, so this particular development, this particular cyclone, it hits the land areas coming on the way. And this is the reason that we see tropical cyclones hitting specifically the eastern coastal areas of India and not that much western coastal areas of India, because they travel under the easterlies and they are coming from the eastern side and blowing towards the western side. These winds, these trade winds. So that's why the cyclones, they also travel with the direction of those winds. And that's why they hit specifically more often the eastern coastal regions. This is one of the most important regions. Now, my friends, for example, this entire development happened, the tropical depression, it turned out to be rotating tropical depression under Coriolis force, and then after, under steering winds, it also started having movement. And when the sustained winds, for example, this is a tropical cyclone, when sustained, I mean the winds, those are spiraling around the cyclone, they become sustained winds having the speed of more than 62 kilometer per hour. This is the global definition. Then that particular depression, rotating depression, is declared as tropical cyclone. So this is the global benchmark. When the particular surface winds, they cross the speed of 62 kilometer per hour that surround the entire tropical cyclone, then the particular tropical cyclone is declared as tropical cyclone. Before that, it remains a tropical depression and not a tropical cyclone. Now the next important thing, the region where the tropical cyclones, they take place. So mostly the tropical cyclones, they take place in between 5 degree to 20 degree latitudes in both of the hemispheres, northern hemisphere as well as southern hemisphere. 5 to 20 degree latitudes. Why? Because the surface temperature of the oceans in the tropical region, it provides that state, it provides that condition where the particular tropical cyclone could be formed. As we know, the minimum temperature, minimum surface temperature should be at least 26 degrees Celsius, and that is found in the tropical regions. So that's why tropical cyclones can only be formed in the tropical region of the earth, Now the next question arises, why only 5 degree latitude to 20 degree latitude? Why not in between 0 to 5 degree latitude, meaning close to the equator line? Why not close to the equator line? Why tropical cyclones are not formed close to the equator region, at equatorial region? So my friends, the reason is here, the absence of Coriolis force. Coriolis force. Coriolis force. Because we have discussed a rotating tropical depression, it needs Coriolis force to become a rotating tropical depression. So since in the equatorial region, there is the absence of Coriolis force, there is almost no Coriolis force. That's why we see that tropical cyclones, they are not formed close to the tropical region. And that's why we say that mostly tropical cyclones, they are formed in between 5-degree latitude to 20-degree latitude in both of the hemispheres, northern as well as southern. Now my friends, the next important thing is that when it crosses, as we have discussed, the benchmark limit, meaning the sustained winds that surround this particular depression, when they cross the limit of 62 km per hour, only then, I mean, this is the global benchmark, only then that rotating tropical depression is declared as a tropical cyclone. And if it is taking place in the northern Indian Ocean region, then it is declared by IMD, Indian Meteorological Department. Now, my friends, the next important thing associated here is that energy, that is energy. Since a tropical cyclone gets its energy from the moisture being supplied by the water body, by the ocean, by the surface of the ocean. As we have discussed, when the warm moist air, it rises up, then vapors in the air, they turn into water droplets, and in this process of condensation, they release tremendous energy, tremendous heat, and this strengthens the entire system. So it means the energy, the heat supplied to the tropical oceans is supplied by the moisture. So when a tropical cyclone, it reaches close to the land area, So upon reaching the land area or the coastal region, the supply of moisture is cut off. The supply of moisture is cut off, my friends. Cut off. And combining few other regions like friction over the land area, there is tremendous friction. So because of friction and various other factors, but the major factor is that the supply of moisture is completely cut off. When a tropical cyclone reaches over the land area, that is called landfall of the tropical cyclone, landfall. So upon landfall, it decimates, it disappears, it decimates, it disappears, because the supply of the moisture is cut off, which was the main driving force of the tropical cyclone. So most often when a cyclone is hitting the coastal region and it approaches towards deeper into the land areas, it gets dissipated, it gets deformed, it gets destroyed, it gets ended up. Because of the supply of the moisture is cut off, this is the primary reason. Other reasons are friction of the land area, which is much larger, much greater as compared to the friction over the surface of the water body as ocean. So these are the primary reasons that the cyclone dissipates upon landfall. Now the next important thing is that how it causes damage, specifically in the coastal region, because it can cause damage only in the coastal region. It cannot go deeper into the land areas, as we have discussed, because there is no driving force. There is tremendous friction as well. So in the coastal region, it causes tremendous damage. A tropical cyclone causes tremendous damage because of storms. Heavy winds are there. As we have just discussed, the threshold, a tropical cyclone is declared a tropical cyclone when the wind speed is crossing the 62 kilometer per hour benchmark. This is a global benchmark. So strong winds are there, they cause storm, and storms, they blow out tremendous infrastructure there and destroys the nature as well, meaning trees, various other animals, various other infrastructure for electricity poles, lines, and homes of the people. So it causes tremendous damage to the infrastructure. And heavy rain, associated heavy rain called squalls. So this heavy rain, it also causes tremendous damage there, specifically in the form of landslides and flooding. So these are the two important things through which a particular tropical cyclone, it causes damage in a particular area upon hitting the coastal region. Now, my friends, the next important thing is naming of the cyclone. So if we talk about the North Indian Ocean region, meaning Bay of Bengal and Arabian Sea, then we see the naming, if any cyclone is taking place in North Indian Ocean region, then that particular cyclone is declared a cyclone by IMD, meaning Indian Meteorological Department, and given a name by IMD as per the list of names, my friends, list of names given by the 13 countries of the region, on the rotation basis. For example, if this is the cyclone, as we are talking about cyclone DITWAH, so it has been named cyclone DITWAH because now the turn of naming was with the Yemen. So this is the name suggested by Yemen in this list, and IMD, that's why declared it cyclone DITWAH, because now the turn was the turn of Yemen to give the name to a particular tropical cyclone. If there is any next cyclone unfortunately takes place, a tropical cyclone, then it will again be named by the name suggested by the next country in the row, as the name given in the particular list as suggested by these 13 countries of the region. And these 13 countries, these are the 13 countries as part of WMO Economic and Social Commission for Asia and Pacific. These are the 13 countries. WMO Panel on Tropical Cyclones. The names are India, Bangladesh, Myanmar, Thailand, my friend Sri Lanka, then after Maldives, Pakistan, Iran, Yemen. The name this time it was suggested by Yemen, cyclone DITWAH, Oman, UAE, Qatar, Saudi Arabia. These are all the 13 countries that are part of WMO panel on tropical cyclones. And the IMD, my friends, it is officially designated. IMD is officially designated. It is officially designated by WMO World Meteorological Organization. World Meteorological Organization. So our IMD, meaning Indian Meteorological Department, it has been officially designated by WMO as RSMC. As RSMC. What does it mean by RSMC? It means regional specialized meteorological center. Regional specialized meteorological center for North Indian region, for North Indian Ocean region. So since IMD is officially designated by WMO as RSMC, meaning Regional Specialized Meteorological Center, so that's why the responsibility lies with IMD to recognize a particular cyclone as a tropical cyclone if it is crossing the threshold limit of 62 km/h, meaning the wind speed, and the name to be attached to that particular cyclone as per the list of names suggested by 13 countries of the region, and to issue advisories. IMD also issues advisories with respect to any tropical cyclone. It gives names. So various things. This responsibility lies with Indian Meteorological Department because it is officially designated by WMO, World Meteorological Organization, as RSMC, Regional Specialized Meteorological Center for North Indian Ocean region. Now, my friends, the next question is with respect to naming, that why naming is there? Why naming? Why? So, my friends, the naming is, the names are given to the tropical cyclones. The reason is the communication. For example, if there are two tropical cyclones, different tropical cyclones. So since the names are there, so there would be a kind of no confusion in communication, specifically in media or anywhere. In advisories, for example, if IMD is issuing advisory with respect to a particular tropical cyclone, since the name is there, so the IMD can say that it is issuing particular following advisories for the particular cyclone, for example, cyclone DITWAH. So this is because of the communication, because of the advisories, because of various kinds of measures taken to protect the infrastructure and the lives of the people from these particular tropical cyclones. That's why the naming is specifically to develop a kind of communication, particular communication mechanism with respect to the particular tropical cyclone. And once the names are given, for example, cyclone DITWAH, the name has been given to this particular tropical cyclone, it will now retire, meaning the name will now retire. It will not be again given to any other tropical cyclone future. The particular name is given once to a particular cyclone. That's how the naming works, and that's why the naming is there. So these are some of the basic aspects, basic concepts that we try to understand in our today's discussion. That could be important for our exam, as we know that questions are synthesized, taking the current development, current incident, and then associating that current development with the static portion of the syllabus. That's why I decided just in this discussion that the discussion is complete, a wholesome discussion, meaning not just discussing a tropical cyclone as an incident, but also attaching the relevant portions with the static portion of our syllabus in geography. So that's why I decided to produce a holistic development with respect to DITWAH cyclone in our today's discussion. I hope that the discussion that we did today in this lecture will prove out to be helpful in our upcoming exams. And on that note, we just wrap up this discussion here. Last but not the least, my friends, I'm glad to inform you that we are going to launch offline batches of general studies foundation course for prelims cum mains, meaning prelims and combined with mains as well. So general studies foundation course, prelims cum mains. So this is a batch which we are going to launch very soon for English medium aspirants of civil services exam, meaning those who are preparing for IAS and PCS exams. So those of you who are interested, they can contact at our center named Rudra IAS, located at Band Road in Elanganj, Prayagraj. Thank you very much. I hope you enjoyed it.